Hello class, today we're going to talk about lesson 6-8, surface areas of cylinders. Our objectives are we can find the surface area of cylinders. Our first vocabulary alert. We need to know what the surface area is. Well, the surface area is just the sum of areas of all the surfaces of a figure. We're also going to need to know what the lateral surface is, and that is just the curved surface of a cylinder. So, surface area of cylinders. In words, we can say that the surface area S of a cylinder is twice the base area B plus the lateral area L. And the lateral area is the base circumference, which is 2 pi times r times the height. So, we have a cylinder in our numbers column which has a radius of 5 and a height of 6 units. So we're going to find the surface area of it. To do that, we're going to first find the area of the bases. To find the area of one base, we would have to go pi times r squared. But there are two bases on a cylinder, so we have to multiply the area of one base by 2. Then we also have to find the lateral surface, or the lateral area. To do that, we're going to have to go 2 times the radius times pi to find the circumference, and then multiply it by 6, the height. When we do that, that's going to give us approximately 345.4 square units. So there are two formulas for surface area of cylinders. The first is S equals 2B plus 2L, where B represents the base area and L represents the lateral area. The formula we're going to use as we go through the lesson today is the second one. The surface area is equal to 2 times pi times the radius squared plus 2 times pi times the radius times the height. So let's find the surface area of this cylinder with a radius of 3 centimeters and a height of 5 centimeters. So let's start by writing our surface area formula that we're going to use, which is S equals 2 pi times the radius squared plus 2 pi times the radius times the height. So we know that R is equal to 3, and we know that H is equal to 5. So all we're going to do is we're going to substitute those two values in to our formula. So our surface area will be 2 pi times 3 squared, or 3 to the second power, plus 2 pi times 3 times 5. Now we're going to use our order of operations to simplify this. So exponents first. We don't have anything to do inside of any parentheses. So 2 pi times 3 to the second power is just 9. Plus 2 pi times 3 times 5. Now we can do the multiplication. 2 times pi times 9, that's going to give us 18 pi, plus 2 times pi times 3 times 5 will give us 30 pi. And now we can just add the two terms. We can think of pi kind of like a variable, so we're going to add the 18 and the 30. So this is 48 pi centimeters squared. So if we wanted to leave our answer in terms of pi, we would be done. But now we're going to use 3.14 for pi to approximate the surface area to be 150.8 centimeters squared. And we're done with our first example. So now let's explore the effects of changing some dimensions. We have a cylinder which has a diameter of 8 inches and a height of 3 inches. We need to explain whether doubling the height would have the same effect on the surface area as doubling the radius. So let's first find the surface area with the original dimensions. Now, if we look at our surface area formula, S equals 2 pi r squared plus 2 pi r h, we need to know the radius and the height. We know the height from our problem is 3, but they don't explicitly tell us the radius. They do tell us that the diameter is 8 inches, and remember the diameter is just twice as much as the radius. So we can just take 8 and divide it by 2 to find out what the radius is. So the radius will be 4 inches. Now we can use the 3 and the 4 and plug them into our surface area formula to find the original surface area before we double any of the dimensions. So we've got 2 pi times 4 squared plus 2 pi times 4 times 3. Well, 4 squared is 16, so we've got 2 pi times 16 plus 2 pi times 4 times 3. Now we can do the multiplication. 2 times 16 is 32 pi plus 2 times 4 times 3 will give us 24 pi. Now we can just add those two numbers that are in front of the pi's to get 56 pi inches squared. And we can leave it in terms of pi because we just want to know how that number in front of pi changes when we double the dimensions. So now let's double the height. Now before we do double that height, we could approximate 56 pi inches squared to be about 175.8 inches squared if that interests you. So now let's find the surface area if we double the height. So remember our radius was 4 inches and our height was 3 inches. So if we can change the height to 6 inches, how will it change? So we've got S, the surface area, is equal to 2 pi times 4 squared plus 2 pi times 4 times 6. Well, we can do 4 squared. 4 to the power of 2 is just 16. So we have 2 pi times 16 plus 2 pi times 4 times 6. And now we can do some multiplication. 2 times 16 is 32. So we have 32 pi plus 2 times 4 times 6 is 48 pi. And now we can just combine the numbers in front of pi to get 80 pi inches squared, which we can approximate to be 251.2 inches squared. Alright, we've got one more dimension we need to double, and that's the radius. So let's double the radius. So we have the radius is 8 and the height is 3. So the surface area is going to be 2 times pi times 8 to the power of 2 plus 2 times pi times 8 times 3. Well, 8 to the power of 2 is 64, so we have 2 pi times 64 plus 2 pi times 8 times 3. Now we can do the multiplication. 2 times 64 is 128, so we have 128 pi plus 2 times 8 times 3 is going to be 48 pi. And when we add 128 pi plus 48 pi, we get 176 pi inches squared, which we can approximate to be 552.6 inches squared. So, doubling the height and doubling the radius do not have the same effect on the surface area. Doubling the radius would increase the surface area more than doubling the height. Alright, let's look at our last example. So our last example is an art application. A website advertises that it can turn your photo into an anamorphic image. To reflect the picture, you need to cover a cylinder that is 32 millimeters in diameter and 100 millimeters tall with reflective material. How much reflective material are we going to need? So let's start by drawing a picture of what we know we need to find. So it is going to be a cylinder. Let's draw ourselves a cylinder. The radius, the diameter of which is 32 millimeters, and the height is 100 millimeters. Now, if we were going to put a picture, are we really going to see it if that picture covers either the top or the bottom base? Not really. So all we need to worry about is the lateral surface area, our lateral surface. So if we're looking at our surface area formula, it is just the part that's L equals 2 pi times the radius times the height. So we know the diameter, we know the height. We kind of need to use that diameter to find out the radius. So we know that the height, or h, is 100, but we can use the diameter, 32, to find the radius. So if our diameter is 32, then our radius is just half of that, or 16. So we're going to plug h and r into our formula. So our lateral area is 2 times pi times the radius, 16, times the height, 100. Now we can do some multiplication. 2 times 16 is 32, and 32 times 100 is 3,200. So we have 3,200 pi millimeters squared if we wanted to leave our surface area or the area in terms of pi, but we don't really want to do that. So we're going to multiply 3,200 by 3.14. And when we do that multiplication, we're going to estimate that that is about 10,048 millimeters squared. So we need 10,048 square millimeters of the reflective material. That wraps up our lesson on surface area of cylinders. For your homework tonight, I would like you to finish the Your Turn problems in your guided note packets for class tomorrow, and we will practice finding the surface area of cylinders when you come to class tomorrow. See you later.